All right, so here's the thing about me. When I talk, I want to be heard. And I don't feel like I'm being heard in class because I'm competing with other people talking. So I'm not going to talk in class. I'm just going to make this video to show you some new information and you can absorb it when you're ready to absorb it. So what are we looking at here? We're looking at rational exponents. Expressions with radical or with rational exponents, they can be rewritten as radicals. And using the following rules, you can do that. Okay, so the exponential form is what you're looking at right here. This is the exponential form, meaning the nth root of a. The nth root of a. So what are you seeing here actually in radical form? If I had to put this in the radical form, I'm saying that the nth root of a to the first, I'll even say a to the first power, if that makes it any better for you, but it's really just a. So the nth root of a raised to the mth power. So that's all we're looking at. So that's the pattern that we typically will follow. So when I say this fraction right here, I give you that fractional exponent, what I'm really saying is you're going to put the n out here, the a here, and the m right there. That is the rule for how these things work. So when I have to convert, look at number one, converting between exponential and radical form. When I look here, I'm going to follow this pattern over here. The 4 represents my my n. The 1 represents my m. So I can rewrite this as the 4th root of x to the first power. Over here, let's check this one out. What am I really saying here? I'm really saying that I have 15 n, and I want the square root of it. I want the square root of 15n to the first power. What about this one over here, number 24? Well, if I'm looking at this number 24 right here, what I'm really asking you for is the third root, the cube root of 24. And what is the cube root of 24? That would be, well, let's see, 8 times 3 is 24, and 8 is a perfect cube, right? So this can break down to 8 and 3, which breaks down to 2, 2, 2. So I'm really looking at 2 radical 3 with an index of 3. All right, number 4, let's check out. Let's check out some more of these. Whiz through them, okay? Number 4 says 7 to the 2/3 power. So again, my m is the 2, my n is the 3. The n goes in the index. So I'm really looking for the cube root of 7 squared. 7 squared is actually 49. So I'm looking for the cube root of 49. And that doesn't break down any further. There's no perfect cube for 49. Let's try a few more. Here I have k to the 7 halves. So that k goes underneath the radical. That 2 is my index out here. That 7 comes down like a hat right there. All right, but this will break down. This will break down. Well, how would this break down? Let's see here. I could have k to the 4th times k to the 3rd, right? And then this k to the 4th. Let me make this a little bit easier for myself, actually, because I'm running out of space. Let me see here. I just have a K, a K, a K, a K, a K, a K, and another K. So I have 7 Ks. I'm looking for the square root, so every pair can come out. So that pair of Ks can come out, that pair of Ks can come out, and this pair of Ks can come out. So I have 3 k's that can come out. That's k to the third. And I have 1 k that must stay under. Okay? Let's try number 6. Number 6. I have 3 right there. And under radical, my index is 4. That's a 4. And my 5 is my M. It goes up here. All right. You can even think about these. You can think about these a couple of ways, right? So, you know, this is. You can multiply this all the way out and go from there. Find the 4th root, but there is no perfect 4th root. I have even seen people, you know, break this thing up. I've seen people break this thing up to where it says something like 3 to the 1 to the 4 fourths. 4 fourths times 3 to the 1 fourth. And if you do that, then now you know you can add exponents, right? But anyways, this whole thing, if it's just 3 to the 4 fourths right there, hopefully that is clear. I can make this a little bit better. So it's 3 to the 4 fourths right there. Well, 4 over 4 is just 1 right here, right? This 4 over 4, that's actually just 1. So 3 to the first power is just 3. And then I can do this index over here. So radical 3, and my index of 4 is right there. So instead of going and actually multiplying 3 times 3 times 3 times 3 times 3 and trying to break that thing down through a bunch of steps, I can split this radical up into an easier thing to approach. So that's kind of a shortcut right there. All right, I'll do a few more. I have AB to the 3/4 power. So again, my index would be 4. I have my AB right here, and it's to the 3rd power right there. To the 3rd power. All right, so I can distribute that, and I'm done. So I'm just going to distribute that 3. So A to the 3rd power is A cubed. B to the 3rd power is B cubed. And that index stays the same. I'm done right there. Right there. All right, number 8. I have a -6. I have a -6x right there under my radical. I know the index is 3, and I'm squaring this thing. All right, once I square this underneath, I'm left with radical index 3, 36x squared. And you cannot find a perfect cube for 36. We see 6 and 6, 2 and 3, 2 and 3. Yeah, you're not going to be able to pull anything else out from there. Number 9, we'll do number 9 real quick, and then I'm going to keep on pushing. All right, let's see here. I'm going to leave this 7 out front all by itself. I'm just going to put that under a radical. So 7, radical 12, W. My index is 2. I'm going to the 1 power, first power. So here I have it. This I can break down a little bit more. This will break down, right? 12 can break down into 4 and 3, and that's 2 and 2. So I can pull out a 2 and leave a 3 underneath, a 3W underneath. So I'll do that right now. All right, wonderful. And so my final answer would be 7 times 2 is 14, radical 3W. Let's do the reverse of it. Let's look down here. I'll do this with you real quick. And we can do the reverse of that as well. So we can write each expression in exponential form. So if I give you a 16 under the radical, you can just tell me that's the same as 16 to the 1/3 power. If I give you an xy under a square root sign, right, the index is 2, so you know that's just xy, both of them, to the 1/2 power. And if I give you this, you can tell me 8w to the 1/4 power. Alright, why do you like this? Why is this helpful? A lot of times this is helpful because we can't do too much with radicals. A lot of times this is helpful because then you can start using your exponent rules if you're adding or subtracting these things. So we'll get that to that bridge later. Let me jump down to 18, something hard down here. Something really hard. If you can do this one, you can do all the other ones, right? So what I'm really looking at is 9x to the 7th, y to the 4th. That is all one number. And I'm taking that to the index is 3, 1/3 power. Alright, I won't do the other 5 on this page. I think you get the picture. Let me see if there's anything else I want to go over in this video. No, nothing else I want to go over in this video.